Hello. Today, we are going to discuss the implementation of IoT using Raspberry Pi. We can implement it in two ways. 1. Software implementation. 2. Hardware implementation. Let us discuss it accordingly. 1. Software implementation. The RPI runs on Raspberry OS, which is based on the Debian Wheezy Linux OS and uses a Python script to operate the appliances connected to it. The user has the following two interface options. A. Web page. B. Android application. A. Coming to the web page. In this, for the development of the web page, implementer on the user and HTML file and JavaScript was used. On the user end, we can use HTML files and JavaScript. On the server end, we have PHP to read the data containing the PO, which is general purpose input-output that is in use, and the device is connected to each room in JSON format. The web page offers control of devices through interfaces, which as follows. There are three interfaces. There are login form, screen for selecting a room, view of the room and corresponding connecting devices. Let's learn it briefly. Login form. The login form is a simple PHP script that interacts with my SQLite database. On successful login, the user can see a screen that lets the person select the room. Next, screen for selecting a room. The following is stored about the rooms in JSON format. Room name, description, type. Each room is represented by a JSON object containing the above-mentioned data for each room. Next, view of the room and corresponding connecting devices. In this interface, it shows the information about the room selected in the previous screen. Each individual is represented with an icon that displays the name, description and status of the device. Irrespective of these, other two buttons are on and off, used to operate a particular device on or off. Here, you can see that initially, we have to log in, then it generates login successfully, then by selecting the device we have to control it by on or off. This is up to the web page. Now, let's quickly learn the next topic on B. Android application. Here, the working of the Android application is similar to the web page. Initially, users have to log into the app using the login screen after the successful login of the user. He or she will ask for extra credentials that are provided at the time of authentication. After this process, users were able to see the selector room of their choice. The room will further contain icons, images and represent various devices that are interconnected inside the room. So the device selected by the user will display certain information like name, description and status of the device, status value for the device to the MySQL database. Here we can see, we perform with username and password then to go button to sign in. Then we will get the control of devices of light, fan, etc. In this way we can use IoT using Raspberry Pi and software implementation. Now, we see how it works under hardware implementation. 2. Hardware implementation. The core of the premise automation system consists of a Raspberry Pi 3 model breadboard. The integration of electronic components into the Raspberry Pi. For hardware implementation we have to some of the electronic components are like A. Raspberry Pi 3 model B. Power supply module for Raspberry Pi, circa 830 points MB102 breadboard. D. Bulb. E. 8-channel DC 5 volts relay module for RPI. F. Smartphones. G. Internet connection for both smartphones. As we can see here, in this way of using all these device connections, we can build the hardware implementation. Next, coming to performance evaluation, let's take a look at how it works in general. Here, we can see the general graph of the performance evaluation. By considering this graph, we can describe that. To efficiently evaluate access on the overall implementation of premise automation using RPI. Here, we have incorporated a multimeter into the existing circuit by connecting it to individual PO pins of RPI. The multimeter was attached to the RPI by connecting its positive node to the PO pin 26 and negative node to the RPI, where the user toggles the power button to turn on it. A PHP script fetches the data of that particular device is on, and stores it in an MySQL table. Respectively, it happens with the same off button as well. In this way, we can see the hardware implementation using Raspberry Pi. And also there are some more interesting areas where the RPI can be implemented. A. Remote camera. B. Chat box. C. Digital advertising screen. D. Android TV. E. Automated printer machine. F. Customizable device. G. Physical computing device. Next. Shortcomings of RPI. They are: A. Varied cost. Pi is advertised to be a very cheap solution to high processing devices. So this varied cost is one of the shortcomings of RPI. B. Limited RAM. RPI has a RAM of 1024 MB in most of the models. This is the major drawback of the RPI, which confines its processing power. Coming to future scope of RPI, there are many other high-end applications for the RPI. One of them is a smart traffic control system. Well, that's the end of today's topic. Along with the video explanations, we offer notes, mind maps, infographics and more to all the subjects from your syllabus. And also career guidance programs from current working IT professionals. And many more to our supporters. To join our supporters community, use the subscription link given below. For more topics from your syllabus, please visit our website given in the description. If you like the explanation, press the like button and rate us from 1 to 5 in the comments section below. For getting updates on any video we posted, please subscribe to our channel and press the bell icon. We will be back with another concept soon.